Hi everyone. Today, please find this warm-up from Canvas. You can download the PDF or print it and work out the answers. Pause this video and then come back to see the solutions, and I'll talk briefly about how we got some of the answers. All right, all of this information was from last class, so we have our mean. We're going to be using this today, so I am going to write some of this in red. The mean of a sampling distribution for one proportion is mu of p hat equals p, and the standard deviation, well, actually, I'll just highlight the ones I already wrote down, and the standard deviation is this formula here. So then we have approximately normal. This is the rule that we use to check the normal condition. It's called the large counts condition. And then we use the normal curve to answer the question. And so if we increase our sample size to 9,000, everything's still normal because we got bigger, but our standard deviation is a third the size because of multiplying the denominator by 9, basically. Pull it out of the square root and it's 1/3 the size. Okay, so hopefully you guys can pause and check over all of these, and if you have any questions, be sure to ask your teacher. All right, so for today's activity, we're going to say we're going to be talking about some M&Ms versus Skittles. So last class we talked about specifically Reese's Pieces being orange or not, and now we're looking at the orange in M&Ms and Skittles. So I, Miss Pendleton, believe that Skittles have a higher proportion of orange candies than M&Ms, but Miss Braylon, the old AP Test teacher, or Mr. Crouch, whichever one you want it to be, believes the opposite. So who is correct? We're going to take an SRS of 50 of each and calculate the number or the proportion of orange candy in each one. So to start off, I do want to just go ahead and tell you that I took the sample myself, and I got 13 out of 50 orange, which is 0.26. And Miss Braylon took hers and got 9 out of 50, which is 0.18. And then to find the difference, we do 0.26 minus 0.18, and we get 0.08. So I want to label a couple of things as a reminder. Remember, this was a proportion from a sample, so we use p hat to say that, and then we'll use a subscript of s for Skittles. And so that's going to be p hat s right there. Here, we'll call this one then p hat m for M&Ms. And then when we subtract them, that gets us p hat s minus p hat m. And so we'll go ahead and do that there. And then what you're going to do now is get your own sample. So if you're in class, hopefully you have some Skittles and some M&Ms, and you can get your own proportion. And if you're not in class, then you can just copy down the dot plot that I show you on the next page before you move on. So like for example, 0.08, I would just put that right there. That's our p hat s minus p hat m. And then every person will get their own, and you can add it to the dot plot, either the Staplet dot plot in class or the one on the board if you're at school. So here's what this dot plot looks like. Go ahead and copy it down so that you can get an sample data. And I'm sorry if you didn't get to collect your own set of Skittles and M&Ms or eat them. That's delicious. But you can still get the class data by copying this down. And then once you copy down this dot plot, I want you to go ahead and complete numbers 3 and 4, and then stop there and get and wait for you to finish this. Sorry, stop there, unpause the video, and then take a couple notes before moving on to the next part. Okay, so hopefully you got this dot plot copied down and you made some predictions. A couple things about this. We're going to label this as, first of all, each of these, remember this 0.08 was p hat s minus p hat m. And each proportion here is p hat s minus p hat m. So each one represents a difference. That's why there are some negatives. So in this particular negative 0.04, the person who got that had 4% more oranges in the M&Ms than in the Skittles. Because when you did Skittles minus M&Ms, you got a negative number. That's important because the order that you subtract needs to be consistent across the board. And we'll call this a sampling distribution because remember, it's a bunch of samples put together. So when you combine samples and each dot is a sample, then, or a set of samples combined here, that's a sampling distribution, and then it's a p hat s minus p hat m, since all the dots in the dot plot are represented by the difference in the sample proportions. So for number 4, we're looking, it looks approximately normal. The center looks to be about 0.04, and the variability, I'm just guessing, like looking, you know, if we go out a couple standard deviations, around 0.02. So you can put anything you want there. There's no wrong answers. You're just describing what you see in the dot plot and making some predictions. Now what I want you to do is go ahead and complete the next slide. Keep in mind the formulas that I reminded you from the first warm-up today. Mu of p hat equals p, sigma of p hat is p1 minus p over n square rooted, and the normal, approximately normal condition for the shape. So keep that stuff in mind and then go ahead and complete the rest of the worksheet and then unpause to check the answers. So go ahead and complete that. Okay, so I'm going to take some quick notes here for us in red. And so what I want us to do is we're going to label from the beginning P sub S equals 0.216 and P sub M equals 0.2. Remember, these are parameters because they describe a population. This is from Google, that is the true proportion. And so that's what we use now to answer the rest of these questions. And I'm just going to remind us some formulas that we've talked about today. So these are all one sample formulas that we're using. And so for the shape, we checked large counts for each one. For the mean, we used mu of p hat equals p. And for the standard deviation, we used sigma of p hat equals square root p 1 minus p over n. So that's where all that came from. And then what we're doing in number 6, 7, and 8 is combining the distributions, which we've learned how to combine distributions many times in our last unit, by subtracting. And so I'm going to label this all as 2 sample. So just know that that's what we're looking at now. And so in the approximately normal, we learned that when you combine distributions, the shape of each distribution is preserved. So it was both normal before, and then the combination would also be normal now. And so the way we can check that in the future is we could do large counts for both. And I'm going to label that as N1, P1 is at least 10, and N1 times 1 minus P1 is at least 10. And we have to check N2, P2, and N2 times 1 minus P2. So you want to check sample 1 and sample 2 to make sure you have large enough counts for each one. For the mean, we learned before that when you're subtracting distributions, you can just subtract the means. And so in this case, that formula is going to look like mu of the difference in p hat 1 and p hat 2 is the mu of p hat 1 minus, well, actually, sorry, just p1 minus p2. So that's what I had labeled up here as ps and pm. So we're just making it generic with 1s and 2s. And now that's going to be the mean for the differences of all proportions like that in the future. And then hopefully on the last one, the standard deviation, you remember that when you combine standard deviations, you square each one, add, and then square root. And so what that looks like formula-wise is that we will basically square this, and add it together, and then square root the whole thing. And so what that turns into, it's going to look crazy, but you'll see how it's not too hard. is the standard deviation of the differences is the square root of P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. So you see the square and the square root will cancel underneath the giant square root, and then that's what you're left with. And so hopefully you were able to use those rules that we had learned in Unit 4, our last unit, come up with this answer. If not, just fix it now and write this formula down. You don't have to memorize this. It's on the formula sheet, so you will get it. I know it's complicated looking, but you don't have to memorize it because they'll provide it for you. And then this last thing, if you look at all this work we did on here, just like last class, we talked about the z-score formula. So 0.08, I'm going to write as small as I can. 0.08 was the difference in our sample proportions. 0.016 is the difference in our population proportions. And the denominator is the standard deviations. I don't have enough room to write the whole formula, so we have sigma p hat 1 minus p hat 2. And that's just that formula that you see right there. On the next page for the notes, you'll get the whole thing for you to write down. But z-scores are always just value minus mean over standard deviation. The value we're interested in is the difference in sample proportions. The mean is the population values, and then over the standard deviation that we wrote down in the previous section. So pause the video to move on, or actually move on, then pause the video to copy all of this down. I pretty much just talked about it. For sampling distribution for the difference in 2, well, you're going to notice there are 2 samples. And so we have the formula for mean, standard deviation, and shape. And then the z-score formula for you to calculate normal probabilities. So pause here and then come back to the video. Pause here, try to check your understanding, and then come back to the video to see the answers. All right, so hopefully you were able to get some of this. The shape, we have to check both. I just like to label them separately, bag 1, bag 2, so that I can see each one checked and know I did both. Otherwise, it's a lot to remember. The mean, this formula, mu of p hat 1 minus p hat 2 is equal to p1 minus p2. Then the standard deviation is this formula. Just plug everything in. To interpret it, remember, it's the typical variation from the mean. And then I checked the 10% condition here to use the standard deviation formula still. And then letter D, that the difference in proportions is larger than 20. It didn't specify bag 1 minus bag 2. So I just did either one being bigger by 20%. Doesn't make the answer that different. If you don't, you'll still get 0.863 something. So no big deal if you didn't do that. I just was being extra thorough there to check difference of 20% in either direction. And don't be alarmed about getting a negative mean. Remember, that just means bag 2 had 10% more than bag 1. So I'll write that down here. And so that's because I did bag 1 minus bag 2. That's why. So I'll unzoom so you can see the whole thing at once. Be sure to ask if you have any questions. And I hope you have a great day. Check Canvas for what's next.